and welcome to the first ever episode of Math in the Kitchen. A name I just came up with because we'll be using the top of my refrigerator as our whiteboard today. So we may stick with that name. Some may call it crazy, I call it genius. So here we go today. We're gonna be talking about multiplying fractions by whole numbers. So when we're multiplying fractions, there's a couple things that we need to start with, just kind of a review to help us remember procedures and things that we need to do when we're multiplying. One, multiplication is the same thing as repeated addition. So, for example, if you have 3 times 2, that's the same thing as 3 plus 3. It's the number 3 2 times. Repeated addition, okay? Also, we're going to be talking about fractions particularly today, so we need to understand the term base fraction. Now, base fraction simply just means the smallest unit, 1 over the denominator, whatever the denominator is, and the number 1 over it. And a way I like to remember what base fraction is when we talk about base words in reading. For example, if I ever stumble upon the word misunderstand, and I don't know what misunderstand means, I know the root word is understand. And so to misunderstand means to not understand. So base words are very similar to base fractions in that we go down to the smallest root we know. So let's take a look at that example today. First example here will be 5/15. And what does that mean? What does that represent? I know that 5/15 in its smallest unit means that I have 1/15 repeated 5 times, because I know 1/15 plus 1/15 plus 1/15 plus 1/15 equals 5/15. Now, because of what I've already set up here, that multiplication is equal to repeated addition, then if this 5/15 is equal to 1/15 plus 1/15 plus 1/15 plus 1/15 plus 1/15, then because of this definition, it also has to mean 1/15 times 5 equals 5/15. So that means 5/15 is equal to 1/15 times 5. So that's how we figure out how the unit fraction is the same as multiplication. But you may say, I understand how to get from here to here, but what do I do on a problem that looks like this? What do I do with 1/5 times 3? Okay, 1/5 times 3, well, I could say, I know it's repeated addition, so I could say, all right, 1/5 plus 1/5 plus 1/5, I'm gonna repeat that 3 times, equals 1, 2, 3 over 5. Now remember, in addition of fractions, we never touch that denominator. As long as the denominator is the same, we just keep the denominator the same. We're just adding them together. We're not changing the size of the piece, okay? But what if I don't want to do addition? What if I just want to do multiplication? That's totally possible. Whenever you have a whole number, you can put it over top of 1. So we would set this problem up a different way, like this. 1/5 times 3 over 1. And then our rules of multiplication can apply. I would say numerator times numerator over denominator times denominator. Now in my class, we affectionately call it n to n over d to d, which just means numerator times numerator over denominator times denominator. And so I'd take 1 times 3 equals 3 over 5 times 1 equals 5. And then I have 3/5. Okay? So you might be an inquisitive learner and you might say, well, Miss Stewart, how come you can just throw 1 under there and it doesn't change anything? Well, let's go back to what we remember about fractions. Fractions are another way to represent division. Fractions can represent division, okay? So what that means is if I have a numerator, 3 over a 1, it can represent division, just like this. 3 divided by 1 equals 3. So that means this doesn't change the value, it's just another way to represent the number. Another example of not changing the value would be calling 2/4. We would also call that 1/2. I did not change the value, I just wrote it in a different way. That's exactly what we're doing when we take whole numbers and we put them over a 1. We're not changing the value, we're just simply writing it in a way that we can use it. So let's take a look at one last example. I'll call it example number 3, and we'll just do it right here. Example 3. Let's say we have, what if we have a 3 on the top and an 8 on the bottom? Okay, example 3. 3/8 times, let's say 4, okay? 3/8 times the whole number 4. Now, I don't have a nice pretty 1 up here like I did in example 2, so I'm not gonna get easy peasy facts this time. I'm gonna have to think about my multiplication facts. Let's go ahead and rewrite this in a way that we can use it. 3/8 times 1/4. 3/8 times, or not 1/4, excuse me, 3/8 times 4. I'm gonna rewrite that now as 3/8, that can stay the same, it's already got a top and bottom, times 4 over 1. Now I can use it. Now I can multiply n to n, d to d, or numerator times numerator over denominator times denominator. So 3 times 4 is 12 over 8 times 1 is 8. So one possible solution for this problem is 8/12. Now, how many of you are sitting there going, the numerator is bigger than the denominator? That's totally true. And so if the numerator is bigger than the denominator, what can we do? What's the word? Reduce. We can make it smaller, or we can make it more usable fractions. So from here, I'm just gonna go ahead and reduce this. How many times can the number 8 go into 12? There's a number of ways to do this, but I like to use long division. I'm gonna say 12 divided by 8, because remember our note up here, fractions represent division. Okay, so 12 divided by 8, 8 can go into 12 one whole time. 1 times 8 is 8. If you don't remember these steps, boys and girls, remember, it's divide, multiply, and subtract, bring it on down and bring it on back. So I did my first step here, divide. 8 goes into 12 one time. 1 times 8 is 8, minus that, 12 minus 8 is 4. I don't have anything else to bring down, so I'm gonna make that 1 and 4/8. Okay, that's another possible solution for this answer. 8/12, 1 and 4/8. But again, some of you are like, Miss Stewart, 4/8 is 1/2. You're totally right. So we could even rewrite this again and say it's also equal to 1 and 1/2. All 3 of these are the correct answer. They're just written in different ways. I absolutely love this math problem because it's using so many skills and strategies that we've learned throughout this year. We're talking about repeated addition being multiplication. We started at the very beginning of the year reviewing that idea. We're talking about how fractions represent division. We've talked about that. Now we're getting into the idea of reducing our answers to get the best possible answer. And remember, boys and girls, sometimes they'll say pick all the answers that apply. So that's why it's super important to know 12/8 is the same thing as 1 and 4/8. It's also the same thing as 1 and 1/2. All right, lots of skills in today's lesson, but feel free to watch it again if you need to understand all the ideas that we've learned here. And I hope to see you next time for another edition of Math in the Kitchen.